In our next section, we're going to look at the hardware specifics of the different Nexus platforms and the MDS platforms, talk about what are the different roles of the devices in terms of how is the 7K different from the 5K and the 2K, where specifically that fits into the design, and then what are some of the functional differences between the different platforms in terms of Nexus versus Nexus, and then also Nexus versus the MDS. Now, where you can find this specifically on Cisco's website is if you go to cisco.com/go/Nexus, you can see the specific data sheets for the different platforms. And then what we are going to be looking at here is down under products and services. You can see the specific Nexus portfolio. And then we're going to be looking at what are the differences, like to compare the models between the 7Ks in terms of what are the different supervisors, what are the different line cards, what are the different chassis options that are available, and why might you want to choose one in your design versus another. Now, before we get to the specifics of that, if we talk about this from kind of a high-level overview, and we look at this from our 3-layer design in terms of core aggregation and access, in general, you would categorize Nexus 9K and 7K as your core layer 2 and layer 3 switches. In the aggregation layer, that's where normally you would find the Nexus 6K and the 5K. So 5K being the 5500 and the 5600. And then down at the access layer where you connect to your end applications, that's generally where you would find the 5K, so the 5500s and the 5600s, the Nexus 3K in low latency environments, and then the Nexus 2000 fabric extender in order to do our what we call the end of row designs, which we'll talk about a little bit later, specifically what that means. Now, in our case for CCNP DC for Unified Fabric, there's mainly going to be 3 of these platforms that we are going to focus on. So I'll talk a little bit about what are the other ones, but the main focus is going to be on the 7K, the 5K, and the 2K. Now, there are, of course, specific use cases for why you would use a 3K or a 6K, and then the new Nexus 9000, which is for the application-centric infrastructure, or ACI. But at least within the scope of these particular exams, they're mainly focusing on the 7.5 and 2 type unified fabric design. So the first of these, which is the Nexus 9000, this is going to be a layer 2, layer 3 core switch, which if we look at the compare models, there's basically 2 different main variations. You have the modular chassis, similar to what you would have as like a Catalyst 6500 or a Nexus 7K, and then you have the fixed switches, which would be similar to like Catalyst 3750, Nexus 5K, or in this case, it's the Nexus 9300. Now, the big difference between these ones and the 7Ks, one of the main ones is that this is a LAN switch, a layer 2, layer 3 switch only. It's not meant to be a storage switch. So it doesn't run FCOE, and it also doesn't run some of the other features that the 7K does. For example, Fabric Path, where instead it runs layer 3 routing and what we call the application-centric infrastructure, or ACI, which is used to build basically an automated fabric in order to do what is called, and let's see if it should say it down here, offers full virtual extensible LAN bridging, routing, and gateway support. This we're going to talk about in more detail when we talk about Fabric Path and what is a data center routed fabric, or sometimes what is referred to as a CLOS fabric, a CLOS fabric. And it has to do with doing equal cost multipathing, or ECMP routing, in order to have any-to-any connectivity and active-active forwarding from the servers to whatever the destination is. Now, I am going to talk about that in more detail later, and it'll start to make sense. What are the different options, and why might you want to use one versus the other? Where the Nexus 9K has a similar logical solution to Fabric Path, but it's implemented differently. And so as opposed to doing layer 2 routing with FabricPath, it does regular native layer 3 routing with BGP behind the scenes, and then uses this protocol called Virtual Extensible LANs, or VXLAN, in order to do layer 2 bridging if we want to extend servers layer 2 connectivity. So we'll see within the Nexus 7K, 5K, 2K design, what are the different ways that we can implement that. One of them is going to be with the overlay transport virtualization feature, where in the case of the 9K, it supports it with this VXLAN bridge. Okay, the next one we have is the 7K, which I mentioned is going to be part of the main focus of our particular scope. And it says that this is ideal for access aggregation and core deployments, where basically you could technically fit this into any of the 3 roles, but in most deployments, you would either see this as the data center core or the data center collapsed core, where it's doing both aggregation and core roles at the same time. Because from an access switch point of view, generally the per port cost is going to be much higher than like a 6K or a 5K would be. So if we look at specifically compare models, and let's look at the chassis to begin with. So this is it's a modular platform, so just like the case of a Catalyst 6500 or the new Catalyst 6800, where it goes down to as small as the 7004, which is a 4-slot chassis, and it gets as big as the 7718, which is an 18-slot chassis, or the 7018, where the 7700 is the new version. That's the second generation. Now, one of the big differences here between the first generation and the second generation is if we go under the I/O modules, which is essentially the line cards. One of the differences is these new line cards, which are the F3s. Most of these are only supported now on the 7700 as opposed to the Nexus 7K. And the big difference, if we look back at the chassis, is how much bandwidth availability is on that particular platform. Where the 7700 goes up to 1.3 terabits per second, the 7018 goes up to 550. And if we look at what are the particular modules that it specifically supports, the 7700 supports the 12-port 100 gig E line card, and these are non-blocking. So it's line rate 100 gig E, and I believe that it supports in the chassis 16 of these. If I'm right offhand, let's take a look at the, let me go back one page to products and services, then down under the Nexus 7K. And let's say data sheets. Actually, I think it's under learn more. There is a section where it shows the specific ports. Here it is. So the Nexus 7700, in terms of 100 gig E ports, it supports up to 192 of them. So in terms of core switching, it's an immensely large amount of bandwidth that you can put into the core of the network. Now, of course, 100 gig E is not going to be going down to your access layer. There's not currently 100 gig NIC cards that go down to the actual servers. So this is meant to be for the core-to-core connectivity, for basically the data center fabric. As we start to go down to the access layer, so either from the core to the aggregation or from the aggregation to the access layer, that's where generally you're going to be running 40 gig E ports between core and aggregation, or between aggregation and access. And then down to the access layer, down to the servers, generally this is where we're going to have our 10 gig E connectivity, or in the case of some of the legacy servers, we can still go down to our 1 gig ports. Now, we'll see that one of the interesting things about the architecture of the 7K, if we go back to that section that talks about the different types of models, so let's say compare models for the 7K. 7K has 2 different types of line cards that are called the M series modules and the F series modules. Now, originally there was only one generation of each of these. They were called the M1 and the F1 cards. And the difference between them is that the M cards were for layer 3 routing, and the F cards were for layer 2 switching primarily. But what this also means is that when we look at the individual features that we want to run on the box in terms of things like regular Ethernet LAN switching versus virtual port channel for doing basically multi-chassis link aggregation or multi-chassis Ether channel, fabric path routing, fiber channel over Ethernet, OTV tunneling, as we start to get into the details of what are those different data center protocols, one of the big things to keep in mind in the overall design is that not all line cards and not all specific ports support all of those different features in all of those protocols. So for example, if we were to look at the M series modules, the newest M card right now is the 2-port 40 and 100 gig EM2, where one of the very common ones that you would see out there is the M132, which is a 32-port 10 gig E card. Okay, this is the specific one that I have in my chassis that I'm going to be doing the demos for. But as we start to go down the data sheets and it talks about what specific features are available, the big thing about the M cards is that they do support MPLS routing, okay, or MPLS switching, you could say. They do support overlay transport virtualization, which we'll see a little bit later what that specifically means. That's one way to extend a VLAN across the routed infrastructure. And they do support Lisp routing. Actually, some of them do support Lisp, but they don't support fabric path and they don't support fiber channel over Ethernet. Now, the other way around, if we look at the F cards and we look at the F series modules, the common ones that you would see out there for the Nexus 7000 is generally the F2E, which is the F248XP. It's a 48-port 10 gig card. There's another one that's not listed here that we are going to be using, which is the F132XP, which is a 32 by 10 gig card. But if you go down and look at the specific features about this, originally the F1 cards did not support layer 3 routing. So the current iterations of the F cards do, both the F2 and the F3 cards. However, there are some caveats that you run into when you're configuring a chassis that has both M series modules and F series modules. So from a real design point of view, this is one of the things that you need to think about when you're building the build of materials, the actual part numbers for the Nexus 7K, is how the modules are going to interact with each other. Now, there's a bunch of specific documentation on Cisco's website that relate to this. If you search for Nexus 7000 white papers, okay, this is a very good reference page here that talks about a lot of the different topics that we're going to be going through in terms of things like I/O consolidation. So what does unified fabric mean? What does the fabric path feature do? What does overlay transport virtualization do? But there's a specific document here that might be of interest to you. That is the, and actually it's not on this page anymore. It is, let me just search for it separately. It would be Nexus 7000 M1 and F1 integration. It's this particular document here, Design Considerations for Classical Ethernet Integration of the Cisco Nexus 7000 M1 and F1 modules. Now, this does change a little bit when you're using the F2 or F2E cards and you're combining those together with the M series modules. But the way that, and you'll see in the examples that we're going to be going through in our particular chassis, the F card is layer 2 only, the M card is layer 3 and layer 2, and the F card can borrow layer 3 routing capabilities from the M card. Now, what this specifically means, if you go down into the details of this particular document, they show you some kind of logical workflows as to what happens when the traffic goes through the cards. And an example of this would be, if I am in VLAN 10 and I want to route packets to a host that is in VLAN 20, I'm going to need to have a layer 3 router that is moving the packets from one VLAN to another. So same as you would in a regular Catalyst enterprise design. So my initiator, my client is in VLAN 10, my server's in VLAN 20. We're in 2 different IP subnets. We need to route to each other in order to get to each other. But the way that the hardware architecture works is that since the F card is borrowing the routing capabilities from the M card, it means that the packets come in and route internally over the backplane, and then turn around and then route back out the other interface in the destination VLAN. So depending on what particular cards that you're using, there's certain cases that are compatible, there's certain cases that are not compatible. So in terms of the F2 cards, the F2 cards are not allowed to be in the same chassis, or what we call the same virtual device context, as the other M cards. Now, this will make a little bit more sense once we start to get into the specific implementation and look at how the line cards are actually allocated, or how they're actually assigned to the 7Ks. But without getting into too much detail of the specific cards, just keep this in mind that if you are building a bill of materials for the 7Ks, you need to make sure that the type of cards that you are purchasing is going to be compatible. And also, there are some limitations that if you take a card like this, for example, the F2E, and you put it in the same context as either an M1 or an M2 card, the end result is that even though this F card does have layer 3 routing support, it disables the layer 3 routing capabilities of the F card, and it borrows them from the M card. So in a case that you may think you might have line rate layer 3 support, based on your specific design, you could get less than line rate throughput when you're combining the different module types together. So beyond that particular document that I mentioned, there are some good presentations on the Cisco Live site that also talk about that. If you search for Nexus M and F, it would be the F3 or the M and F2E VDC migration use cases, and then versatile architecture of the 7K with a mix of F and M modules. Okay, also if we go back to the specific F cards and we look at the other features that they support, they do all support Fabric Path, and they do support Fiber Channel over Ethernet, but not all of them support overlay transport virtualization and Lisp routing, and then also MPLS routing. Okay, the newer cards, which are the ones over here, the F3s, basically support everything. The older ones, the F2s and the F2Es, only support a certain subset of the particular features. So it works a little bit differently than some other platforms you may be familiar with, like Catalyst 6500, where generally the layer 3 capabilities are in the supervisor, and then any of the line cards can borrow the routing engine, like the MSFC and the policy feature card that's in the supervisor. In the case of the 7K, though, these are functions of the line cards directly, so you need to make sure that you have the compatibilities between them. Okay, the next one that we have is the 5K, which I mentioned. The 5K is normally going to be either your aggregation switch or your access switch. So right now, there are currently 3 generations of the Nexus 5Ks. So if we go back to that main page, which was cisco.com/go/nexus, and then down to products and Nexus, Nexus 5000, so let's say compare models for this. The one that is above this, the Nexus 6000, this is used for our end of row design, which we're going to talk about a little bit later, specifically that relates to the fabric extenders. And the main job of the Nexus 6K is to give 40 gig Ethernet access down to the fabric extenders so we can have very high density server blocks. So the functionality and features between the Nexus 5Ks and the 6Ks are fairly similar. The difference is going to be the port density between them. So if we look at the data sheets on the Nexus 6K, and we look at the, let's say at a glance for the 6K. Let's see if it shows the port numbers. So the 6004, this is a 4-rack unit box that is 10 and 40 gig E. And it should say here specifically how many it can take. 96 ports. So it's up to 96 ports of 40 gig E. And then basically you would take these 40 gig E ports, you would connect them to fabric extenders, which fabric extenders are going to be used for essentially remote line cards to connect directly to the servers. So we're going to talk in more detail specifically what the physical design of this is going to look like. But basically where you would put the 6K is the 6K is going to be in the middle in aggregation. This is then going to connect down to the fabric extenders at the access layer. And the fabric extenders are then going to go down to your physical servers. So this could be, for example, the UCS C-series servers that have uplink bandwidths that go to the Nexus 2Ks. The Nexus 2K would then go up to the Nexus 6K, and this uplink is going to be a 40 gig E uplink. Now we'll see that the new Nexus 5600 also now does support this. It does have 40 gig ports, but the 6K was the first one to come out with the 40 gig E versus the regular 10 gig, which is in the 5500 and the previous generation before that, the Nexus 5000s. So from a functionality point of view, you'll see that the 5K and the 6K are pretty similar to each other, but it's a little bit more common to see the 5K in deployment than the 6K, because the 5600 is going to be pretty much the same type of features that you would have previously seen in the 6K. Okay, so under the Nexus 5000s, if we compare the models, the one that we're going to be using here for the class demonstrations is the 5548 UP, which is a 1-rack unit box that is, it has 48 fixed ports, and then it has, actually no, it doesn't have 48 fixed ports. It has 32 fixed ports. So basically the box looks like this. You have 32 ports here, and then you have an expansion module that can take another 16 ports. Okay, the next one, the 5596, is basically the same as the 48, except it's 2 rack units high, and it gives you 4 expansions. So you have one here. Well, actually, technically, that one is built in. So you have 32 plus 16, you have 48 on the bottom, and then you have another 3 blocks of 16 on the top in order to get to the total of 96 ports. Now, we'll see specifically, if you look at the part numbers here, the first 2 that are listed are the 5596 UP and the 5596T. Now, the T model is the one that uses 10 gig copper. So these are regular, if it should say it here. Let me see if it shows the, let's look at the physical view of this box. It uses 10 G-base-T. Okay, so this would be, for example, if you have an Intel 10 G-base-T NIC card, which would be what the next generation servers are coming out, and let me look at one of the actual NICs. Would be something like this. So it looks like a regular NIC card like you have in your desktop or your regular server. The difference is that it runs 10 gig E over Cat6e. So it's a regular RJ45 port like you have in your regular Catalyst switches, but there's a new spec to run 10 gig E over a short distance over Cat6e. In the previous iteration, this is a relatively new standard that came out for the 10 G-base-T. So most of the other switches, these ports are all small form factor pluggable ports, the SFPs, which means that you choose whether it's going to be a copper port, whether it's going to be a multi-mode fiber, or whether it's going to be a single mode fiber. Now, one of the other main differences from a functionality point of view, though, is that the T version This is going to be used for Ethernet only. The UP means that this platform has what is called unified ports. Now, unified ports, we're going to take a look at in much more detail later when we look at the specific implementation, but what this allows us to do is to run the port as an Ethernet port, so just like a regular LAN switch, but we can also change it into native fiber channel mode, and it's going to behave like a port that you would normally see in an MDS SAN switch. So this is one of the big delimiting factors between the Nexus 7K and the 5K, is that the 7K is an Ethernet switch only. The Nexus 5K is both an Ethernet and a fiber channel switch. Now, we'll see once we start to get into more details of the 7 versus the 5, we'll see that the 7K does support fiber channel over Ethernet switching, but it doesn't support native fiber channel switching. So this means from a layer 1 connectivity point of view, there are certain cases that the Nexus 5K would be preferred over the 7K if we're trying to talk to a native fiber channel switching infrastructure. So as I mentioned before, those particular documents on the Cisco design zone. So if we look for Cisco data center design, and let's go to the design zone for data center, we'll go to networking infrastructure, and under Cisco validated designs, we're going to go to the design summary. Okay, one of the first things this shows is the kind of physical cabling and where the different devices would fit into the particular topology. And one of the things that it shows here is that as we have the 5K connected to the servers, we're using this for running both data, so the regular LAN switching, but also for storage, for fiber channel switching. Then as we go to break this traffic out, as we go up to the regular LAN, we see that we have Ethernet traffic that goes to the LAN core. So the LAN core might be like a Nexus 7K, or it could even be like a Cat 6500 or 6800. But also we see going to either a fiber channel storage array or the Cisco MDS switches. These are native fiber channel links. And this is a feature that is specific to the Nexus 5K that is not supported on the 7K. So when we look at the 7K and we saw that there was two different types of modules, the M cards and the F cards, both the M cards and the F cards are Ethernet ports only. But in the case of the Nexus 5K, it supports not only Ethernet ports, so 10 gig E, it supports unified ports, which are the ones that are the as I mentioned, denoted by the UP part number there, and it supports them as 8 gig, 4 gig, 2 gig, and 1 gig fiber channel, in addition to an expansion module which allows you to run multiple native fiber channel ports. Okay, the disadvantage though is that these don't support 100 gig E. So if you need that level of bandwidth density, that would be the Nexus 7K. It does support 40 gig E, and especially when you look at the newer versions, which are the like the 5696, which is the larger version. You can see this looks kind of similar to the Nexus 6K, and this supports, and I'm not sure exactly which module this takes. I believe that these are 40 gig cards. So this one supports 96 40 gig ports or 3200 gig ports. So for very high bandwidth intensity applications, you would have a Nexus 7700 in the core with the F300 gig ports. Then down in the aggregation, you would have the 5696, which has the 100 gig uplinks going up to the 7Ks, and then either the 40 gig or the 40 gig or 10 gig downlinks that would go down to either your fabric extenders or down to the actual servers directly. So you'll see that there's lots of different variations of the part numbers. It just really depends on do you want layer 2 switching only or do you want layer 3 routing? The 5500 was originally designed for layer 2 only, with a layer 3 add-in card as kind of a side note afterwards. The new 5600s have built-in layer 3 line rate on all of the ports. So it's layer 2 and layer 3 now. Then the other thing is, what is the port speed that you want? If 10 gig is fine, that's the 5548 or the 5596. For the new 40 gig and 100 gig ports, those are the 5600s, and then the Nexus 6K or the 7700s. Now, as we go down further, there's the Nexus 4000. This is a very specific application. This is a Blade series switch that connects into an IBM Blade Center server. So instead of having all your physical cables like go up to the top of the rack, you would plug this directly into the Blade Center and then uplink the switch through the backplane of the server directly. So it's kind of like how an I/O module works in the UCS B series blades, but it's Nexus switch working in the IBM Blade Center as opposed to the UCS blades. Okay, so that one's a very specific use case. The Nexus 3000, these ones are used for low latency environments. Typically, they're used for high frequency trading in financials. And the big thing about the Nexus 3K, it's not about features, it's about the port-to-port latency, where when the frame comes in, you want to make sure that you can copy it to the other ports or move it between ports with the least amount of delay in the backplane. So if you look at specifically on the compare models for the Nexus 3000s, the big thing is going to be the switch latency. So in the case of the 3064 and the 3016, they have sub-microsecond port-to-port latency. Where most of the other features like layer 3 routing, you normally wouldn't run this on a 3K because it's just going to be for getting the layer 2 LAN traffic port-to-port as quickly as possible. And again, as I mentioned, the main application for this is going to be in financials and high-frequency trading, what's called HFT. Okay, the other one that's going to be within our scope is the Nexus 2K. Now, the Nexus 2K, the fabric extenders, is kind of a unique box in the terms that it's not an Ethernet switch. It's basically an extension of another switch, similarly to what a line card would plug into your Nexus 7K, or what would plug into like your Catalyst 6500 or your Catalyst 6800. And what this allows us to do from a layer 1 physical wiring point of view is to implement what is known as the end-of-row design for the management of the physical switches. So we're going to come back to this in much more detail to look at specifically how you would wire the fabric extenders and then how are they managed. But the big thing to remember about this is that if you were to buy a Nexus 2000 and plug your servers into it, the servers won't be able to send any traffic between each other. The Nexus 2K requires that you have another switch that is controlling the management for it. So whether that's a Nexus 5K, like a 5500 or a 5600, it could be a Nexus 6K or it could be a Nexus 7K, but on their own, the fabric extenders cannot forward any traffic. They're relying on an upstream switch in order to make all the forwarding decisions in the control plane and also to actually manage the switch from a configuration point of view. Okay, so there's a couple of questions here. If the F3 cards support every technology, why do we need the M cards and can we use the only the F3s? Okay, so this is specifically for the Nexus 7Ks. And the answer is basically you don't need the M cards anymore. But the difference is that the F cards are not supported on all of the chassis. So the F3 is mainly for the 7700, which gives you, you can see like a 48 port 10 gig. On the Nexus 7K, the F3 is only 12 port 40 gig or 6 port 100 gig. So it really depends on what your physical design is. Like if you wanted to use the F3 card to be your OTV tunneling endpoint, you would have to make sure that you have a 40 gig device or a 100 gig device on the other end, and you may not have that in your particular environment. Then when you go down to look at the specific features, when we look at the the tunneling and the layer 2 features. And this is, I want to say it's this one. Actually, no, it's the third category here. This is F3, that way. These are F2E. So basically, they support everything that the M cards and the F cards did separately, but now they're supported together. So in a new deployment, ideally you would buy just F3, and then that's going to be able to run whatever different features that you want to. But the point being is that most current deployments don't have all of these cards because they may, maybe it was deployed a year or two ago, and then you need to manage that solution. It is important to understand how the different cards interact with each other and what features are and are not supported when you go to combine them together.